We're having issues.
It's okay. So what do we got tonight? Stuff you can verbalize?
Yeah, I just want to go over a few problems that I got wrong on the test I did.
Okay.
And then we'll do the other stuff. So first one is 64x squared.
Hold on. Excuse me. One moment. I forgot to turn this thing on. 64x squared.
And then 12x 49.
You're breaking up just a little bit on the audio. What comes after the 64x squared? I'm not hearing you, Blake. Say something. I'm not sure if you're talking or not.
Hello?
Yeah, I can hear you now. What happened? Did you do anything?
Hello?
I can hear you, but you apparently can't hear me.
Yeah, I can hear you now.
You can hear me now. Okay. What comes after the 64x squared?
Plus 112x plus 49.
Okay. And we're supposed to factor this?
Yeah.
Okay. What's our first step in factoring this going to be?
Well, you would do 64. Well, I mean, first you could take out a greatest common factor, I think.
I would look for is I would look to take out a greatest common. But almost rule that out instantly because there are not that many numbers that divide into 49. Remember that the greatest common factor has to divide into each of these three numbers equally. Oh, only 7 divides into 49. 7 doesn't divide into 112. And 7 doesn't divide into 64. So there's no greatest common factor. So you have to factor it. Now, this is a kind of a ridiculous factoring problem. But what is the most likely way to factor 64?
8 and 8.
Okay, so it'd be what? This would have to be 8x and that would have to be 8x.
Right.
Because those two multiplied back together would give you that first term of 64x squared. Now, what are both signs?
Positive, so plus.
And what's probably the only way you're going to factor 49?
7, 7.
Now, does that happen to produce that middle term? Well, let's check the inside. Let's check the outside. That's 56x. That's 56x. They add to 112x. Bingo. That is the middle term. So they gave you this problem that had a ton of possible solutions. And the reason being is that there are so many factors of 64. I mean, we guessed at 8 and 8. It could have been 4 and 16. It could have been 2 and 32. There are so many different factors of 64. And then having all these factors of 49. So I'm surprised that they would give you this problem on the test. I imagine that the reason they gave it to you on the test was they wanted to see if you would try the most likely outcome. In other words, when I teach people to factor numbers, I always say take the two that are closest together. Well, 8 and 8 are about as close together as you can get. So I'm going to start with 8 and 8 and see if that works. And same thing with 49. 7 and 7 are as close as it gets. The only other factors of 49 would be 49 and 1. So I'm going to just try those two close numbers and see if it happens to produce it, and it does. But otherwise, you're not going to get problems like this. There's no way they would give you a problem like that. Make that number 48 instead of 49. They're just too hard. But go ahead. What else you got?
All right, I got one more. All right. So, all right, no, we did that one. Let's do this one then. 2x cubed.
Is that 2x cubed like that, or did you mean?
Yeah, like that. Yeah.
Because there's a difference.
Yeah, the first one. 2x cubed plus 3x squared.
Okay.
And then plus 2x plus 3.
What's this called? What kind of polynomial is this?
Wait, trinomial?
Is it a quadratic?
Yeah.
No? You go by the highest degree. It's got an x squared term in it, but that's not the highest degree. The highest degree is this x cubed. So this is a cubic expression. Okay? And cubics are unbelievably hard to factor. Just as a warning. Except in one situation. And that is where the ratio of the first two coefficients is the same as the ratio of the second two coefficients. Well, the first two coefficients is 2 over 3, right? By the second two coefficients, I mean that one and that one. Well, that's also 2 over 3. Whenever that is the case, then there is a relatively easy way to factor. It's not a 20-minute problem anymore. You can use a technique that's called grouping. And it's pretty much exactly what it sounds like. I'm going to group those two terms together, and I'm going to group those two terms together. And then I'm going to treat them separately. Now let's take the expression in the left parentheses. Can you take a greatest common factor out of that? What?
Or x squared.
Okay. So I'm going to put x squared there. What's left over?
2x, 2x plus 3.
Now let's take a greatest common factor. There isn't one. But we still have that 2x plus 3. Actually, I can put a 1 right there. The problems they give you would be so much more understandable if they didn't use the numbers that they use. But nonetheless, okay, you've spent your whole life factoring monomial terms out, right? This is different. You can factor out a binomial term as long as it's the same. Remember what factoring is. It means I'm going to divide both terms by 2x plus 3. So the 2x plus 3 comes out in parentheses. Now what's left behind?
The 2x plus 3? Or?
No, I'm factoring that out. So I'm dividing each term by 2x plus 3. What's left over?
X squared plus 1.
There you go. And that's why I put that 1 in there. Because if I hadn't written it in there, then it's confusing. That's why I don't like this problem. It's better if there's a number in there. In terms of understanding how you can factor out a binomial term. And there you go. There's the answer right there. Now, I can't go down any further because you cannot factor the sum of perfect squares. If that was x squared minus 1, I'd be able to factor it one more level. I'd be able to turn that into x minus 1 times x plus 1. But, as I said, the sum of perfect squares does not factor. So this would be our final answer. So, understand this, that when you get a cubic, know that it almost certainly can only be solved by grouping, because you're 2 years away from learning how to solve cubics by other methods. In other words, they're never giving you this problem right there. Because now the ratios are 2 to 3 over here and 2 to 4 over here. They're not the same. They have to be identical for you to be able to use grouping. So the only way that they're going to give you a cubic problem is if you can use grouping. Now, they can give you some of these that are more difficult. And we might as well talk about this now, because you're almost certainly going to get one that has a negative sign. Let's turn that negative and turn that negative. Now, the reason this is such a different problem is the following. In the first problem, first of all, check the ratios. What are the ratios? Are they the same?
Yes.
Yeah, they're minus 2/3, both of them. The problem is I can put parentheses around that, nothing changes. I cannot put parentheses around that. I just changed it. Notice that if I remove those parentheses, what I now have is minus 2x minus 3. So you have to be careful when you group these. If that second binomial expression has a negative sign in front of it, then you have to group it to account for that. In other words, I can still do this. That doesn't change that expression, putting the parentheses around it. But now I have to do this. Notice how this second row is identical to the first row. Correct? You remove the parentheses and distribute this negative sign, you get minus 2x plus 3. And when you're doing math, when you go from one expression to another, and your intent is not to change it, but just to rearrange it, always check right then and there if you've done it correctly. Don't wait until you get to the end of the problem, because if you've made a mistake, you won't know where. You just have to start at the beginning again. Whereas if you check along the way, you'll be safer off. Okay? Now, I can still factor out that x squared, leaving behind 2x minus 3. And I can still factor nothing, but we're going to factor out a 1 for a very good reason. One thing, it makes it more understandable. Now, what are we going to factor out of this row here?
A 2x minus 3.
Very good.
Squared minus 1.
And notice that x squared minus 1 is the difference of perfect squares. So it actually factors again into x minus 1 times x plus 1. So not only do we have to treat this differently at the second step because of this minus sign right there, that minus sign made all the difference, but it happens to leave us with difference of perfect squares, and I can factor it again. So now I've gotten the original expression down to 3 linear factors. Linear meaning it's x to the 1 power in all 3 factors. There's no x squared there, or x cubed. Okay? So that's how you handle a negative sign when you see one, between the first 2 terms and the next 2 terms.
Okay.
Now, I don't know if they've given you one like that or not, but what else you got? I mean, you don't have to find one like that, but if,
all right. 5x squared minus 80. This was the last one.
X squared minus 80 or 2x?
5x squared. 5x squared minus 80.
Okay. When we see this, some number, C, what do you think immediately? There's no x term in there.
Mm-hmm.
Dopes. Difference of perfect squares. Because that's a perfect square. We're subtracting them. If C is a perfect square number, boom, we know exactly how to do it. We're going to use dopes. Dopes is the second thing you should check for immediately after checking for greatest common factor. So let's check for greatest common factor. Let's see if I can remove one of those first. Because at this point, this does not qualify as dopes. The reason it does not is because that is not a perfect square, nor is that. So that is most definitely not the difference of perfect squares. But what happens if you take the greatest common factor out?
It would be 5 and then x squared.
Minus 16.
Yeah, 16.
Now, that is dopes. So how does that factor?
It would be x on both sides, and there'd be a minus 4 and a plus 4.
So look for that. In other words, when you see something that looks like it should be dopes, see if you can turn it into a dopes problem. And the way you do it is by taking out a greatest common factor. And it's always going to be like that. They're not going to give this to you if that's a 79. Because then there's no way to do this. So you can bet when you see something that is missing an x term. In other words, if I have something like this, there's no x term, right?
Mm-hmm.
So I could think about greatest common factor, but I happen to be looking at difference of perfect squares. That's a perfect square, and that's a perfect square, and they're being subtracted. So how does that factor? Just figure the first term all by itself. This is not like other factoring.
4x and 4x?
Well, it's 4x minus 6.
Oh, wait,
In
yeah.
other words, you take the square root of that term, you get 4x, and you take the square root of that term, and you get 6. And now the second part of it, you don't have to do any thinking at all. You know what it is. What is it?
4x plus 6.
Yeah. So you don't factor these normally. You don't do it like I taught you how to factor. You don't have to figure the signs. You just figure out the first term. Once you get the first term, then the second term is just the, can't think of a word, conjugate of that.
Mm-hmm.
Where it's the same two things, it's just a different sign in between them.
Mm-hmm.
All right. Blake, I'm going to let you go. Hopefully that took care of. Or do you have any others from your test that you missed that you want to look at?
Nope, that's it.
That's it? Okay.
Mm-hmm.
You have a good rest of your evening. I'll talk to you next time.
Yeah, you too.
Bye-bye.